Hello! Sorry I'm late. Hi everyone, welcome to this AimHi Live. This one is going to be about what are the tipping points for our climate. And already there's so many of you in the chat. Sorry, that was actually why I was a bit behind, was because I was just looking at how many messages are already in the chat. So, yes, just going to say hi to some people. So Melodoan is Max. Hi, Max. Now we know your name. Max, Angel, Jeff's back, Pumpkin Master's back, Japan Maple's back, Jasmine's back, Kieran's back, Jeff's back. Hi, everyone. Thanks so much for coming. So let's start. Today is going to be about, as I said, it's so bright in here because the sunshine. I can't even see what I'm doing. There we go. What are the tipping points for our climate? What are the tipping? Hi Oliver as well. Oliver's in too. Right. What are the tipping points for our climate? Is the order of the day. So before we get into that, I want to ask you guys if mysterious. Let's see what's happened here. There we go. Yeah, before we get into that, I want to ask you guys if anyone saw the meteor shower last night. Did anyone see the meteor shower that happened last night? There were, I think, maybe 10, 20 shooting stars at every single every hour or so. Did anyone see this? I think it was mainly in the UK. I'm not sure, but in fact it was probably visible on the other side of the world as well. Japan Maple didn't know it happened, and Angel's saying there was a meteor shower. Okay, so for those who missed it, don't worry about it. It is fine. But I think what's going on is that because everyone's in lockdown, everyone's getting really excited about things that are actually quite small. So the meteor shower last night was actually a very small one. It was a very, very small one. So these meteor showers tend to happen when a comet. So a comet. Does everyone know what a comet is? I'll just remind people. So yeah, if you've got the sun in the middle, and then you've obviously got all the planets orbiting it. In fact, does anyone know what's the difference between a comet and a meteor and a meteorite? Who knows these things? And don't worry if you don't, but let's see who does. Comet, meteor, meteorite. Do people know what each of those is? Japan Maple saying it's on fire. Wait, what's on fire? And Mia's saying, sorry that you're late. Mia, don't worry about being late. It's absolutely fine. We haven't started yet. We're still talking about comets and the meteor shower and the shooting star shower last night. Okay, Oliver didn't know the difference. Comet is the one with the ice, right? Yeah. So comets. Well, actually, meteors can be made of ice as well. Comet is in space. Comet's made of ice, I think. Okay, so bits of comet generally can become meteors and meteorites. This is all just like, they're words that you hear quite often, but I'll just tell you what each of them means. So, a meteor. So if this is the Earth here, and this can be our atmosphere. Let's do it as blue. So this is our atmosphere surrounding us, and this is us here on the Earth. Then a meteor is any object that enters the atmosphere and starts to burn up. So generally you'll see these, and a lot of people will call them shooting stars because it'll be a bright streak that'll go across the sky as it starts to burn up in the atmosphere. Why? We are not talking about the tipping points of climate. We will do. But why is it that these objects burn up when they enter the atmosphere? Why does that happen? Does anyone know? And Jack's correct as well, saying that meteors coming in through the atmosphere. And saying that comets are in space. And Kieran's spot on with the answer about why they burn up, and so is Jeff. It's to do with friction. Very quickly, by the way, if you're joining late, don't worry about it. We haven't started talking about what the tipping points for our climate are yet. This is an AimHi Live, and so people can ask questions whenever they want, and so things sometimes get steered off in interesting directions. We are currently talking about comets, meteors, and meteorites. What's the difference? And we're talking about the meteor shower last night and why that happened. So, a meteor will burn up when it enters the atmosphere because it's going so fast, and the friction of the atmosphere is immense. So you know how people say if you jump into water from a high enough height, then it feels like concrete because you will hit it so fast. It's kind of a similar thing with objects coming from outer space and hitting the Earth's atmosphere, they are coming unbelievably quickly towards the Earth because there's never been anything to slow them down. And so they hit the atmosphere at incredible speed, and then they just like the friction as they scrape through the particles in the atmosphere just completely burns them up and destroys them. So that's called a meteor. Meteor is one that enters the atmosphere, and then meteorites are the ones that get really lucky and actually make it to the ground with still some of them remaining. Meteorites. So one of the ancient there was like a boy king of the Egyptians called Tutankhamun, and he had a dagger, a special ceremonial dagger that was made from alien iron, because it was made from metal that came from a meteorite that landed somewhere near Egypt, and they were like, well, this is a cool thing for our king, and so they made it into a dagger. So Tutankhamun had an alien dagger made of meteorite. Okay, Lumix is coming in with the actual reasoning about why meteors burn up. Yes, you are absolutely right. Lumix, you're talking degree level stuff, which is great, but I'm just giving people the introduction to meteors and comets at the moment. But thank you for throwing that in. For those who want to know more about why meteors and meteorites burn up, it's something called adiabatic compression, and I won't go into that now. Right. Okay. So comets. Comets are objects that orbit the sun, but they do so in a different path. So all the planets are orbiting the sun like this, in these nice ellipses, and then comets orbit the sun like this. And so at some stage they're very close to the sun, and then they get flung out and they go very slowly. And there's this amazing relationship called Kepler's law that tells you how quickly they move. But basically when they're going around the sun, they go super fast, and then they go really, really slowly around the far bit. And so they basically spend most of their time really far away from the sun. And then when they come close, that's generally when they come close to the Earth as well, because we're quite close to the sun. That's when we start to see them streaking through the night sky. And there's loads of cool stuff going on with their tails as well. But oh my god, I need to get on to the tipping points for our climate. But still, a comet will kind of spin around the sun really, really quickly. And as it goes near the Earth, bits of it will be breaking off. And a lot of those bits will become meteors and maybe even meteorites, and fly towards the Earth. And that's why we had the meteor shower last night, was because of a comet passing by. Now I've got a picture here of a comet called Comet West, which is called a Great Comet because Comet West, because when it passed next to the Earth, it was so bright that it just lit up the sky like 1,000 suns, people would say. And yeah, it was just one that came extremely close to the Earth, and so it was very, very, very visible. And this is a picture taken with just a totally normal camera. I mean, this is what you would have seen. This isn't like a telescopic thing, and there are pictures like this all over the internet. Anyway, right, so it's time to talk about the tipping points of climate. Before I get going, I just want to catch up on the chat quickly. But before I do so, just one last welcome to people joining late. This is an AimHi Live, so I'm going to talk about what the tipping points are for our climate. We've just been talking about the meteor shower last night, but we're going to move on now. If you want to find out more about these later on, because there are loads of these happening, and I'm not the only one doing them, then you need to go to this website for afterwards. And Max is saying that Kanye has got a comet named after him. That's such classic Kanye. And the Pumpkin Master is saying that there was an astronaut called Vladimir Komarov who died through space. I don't see this. And Japan Mobile saying that they want an alien knife. I want an alien knife as well. And Posy's asking, how long have I been live for so far? I don't know, like 10 minutes maybe? Not long. And Max is asking, are astronauts entering the atmosphere also meteors? And the answer is kind of, and that's why space shuttles have so much protection from heat, because they're re-entering the atmosphere, and they will inevitably re-enter the atmosphere very, very rapidly. So they have to slow down as quickly as possible and dissipate as much heat as they can. And if anything goes wrong with the heat insulation on any of those silica tiles that you see underneath, those black tiles that you see underneath the space shuttle, if anything goes wrong and those tiles get ripped off, then the whole of the space shuttle will just burn up and be destroyed. So it's very, very dangerous for entering the atmosphere, because yes, you are a meteor, and then hopefully you become a meteorite as a space shuttle, which is tricky situation. Okay, right. So let's talk about some of the tipping points for our climate. I'm gonna first talk about trees. So if you were on the live this morning, or the one that I did on the Sound of Stars, I think I did it on Monday, then you will know that there are way more trees on Earth than there are stars in the galaxy. There are about 3 trillion trees on Earth. Now, do people think trees are something to do with a tipping point for our climate? And if so, why? Why are trees something to do with a tipping point for our climate? What do people think? And while people throw in their thoughts on that, I'm just going to catch up on some of the chats. There's been so much here. Japan Maple saying we're good at tangents. Yeah, we love tangents, as long as they're interesting tangents. But first, trees. I love trees. Okay, so Japan Maple is saying they absorb carbon dioxide. And Bailey's saying that they are... Oh, wait, you think they're small planets, but... Oh, Kieran's asking what's an asteroid. Sorry, okay, one more tangent before we go on. Asteroids are objects made of like various materials. So here's the sun and then the planets orbiting it. Asteroids can be made from rocks or ice or metals or all kinds of things, but they're classified as the things that just orbit in a nice and steady orbit. So they're just orbiting around the Earth. And actually, if you line up the planets, you've got Mercury, Venus, Earth, Mars, and then a big belt of asteroids before you get to the gas giants. I don't know if you've ever seen that Star Wars episode. I can't remember which one it is, where they're like flying through the asteroid field and there's just loads of rocks all over the place. That's kind of what it's like. But yeah, asteroids are those ones that are just peacefully orbiting in a nice ellipse. Comets are the ones that do this crazy orbit where they go super fast here and then super slow here. And then meteors and meteorites are the ones entering our atmosphere, trying to get a little piece of Earth. Anyway, so yeah. Let's see what people are saying. So trees we need to absorb carbon dioxide, right? So first just the basics. So the problem with our the thing we worry about with our climate at the moment is that there are loads of greenhouse gases being pumped into the atmosphere. So greenhouse gases are this gas. So this is going to be the Earth, and then this is going to be our atmosphere around the outside. So the problem is, and this is like a weird quirk of how light energy works, the problem is that the heat energy from the sun coming in just goes straight through our atmosphere, most of it. But then when heat is re-emitted by the Earth, so the Earth takes in this heat, heats up, and then is constantly emitting heat as well, the heat that it emits is actually it's a slightly different frequency, a slightly different wavelength. And this slightly different frequency heat that's emitted gets absorbed by these things called greenhouse gases. So you will have heard of greenhouse gases, I'm sure, and the classic ones are, of course, CO2, methane. Does anyone know an even more potent greenhouse gas than CO2 or methane? Chuck some in if you know any. But these greenhouse gases absorb the heat radiation that's leaving the Earth, and then when they emit it back in every direction, and some of it is emitted back towards the Earth. And the heat that's emitted back towards the Earth just heats it up more. And so it's not the same as a greenhouse, but we imagine it as like this kind of insulating layer that keeps the heat in. And what's going on with our climate at the moment is that we have been increasing the CO2 levels so rapidly that the temperature of the planet is going up way more rapidly than biology can really cope with. Because biology, we've got some great suggestions in here for super strong greenhouse gases, and those are all spot spot on. H2O, nitrous oxide, water vapor is one of the big ones I was thinking of, because that's one that people don't think is so bad. And we don't worry too much about water vapor because it is a natural part of the system, but it certainly is a big greenhouse gas. And sulfur hexafluoride, great suggestion. There was a big controversy over that recently because they were using it in wind turbines to allow them to turn smoothly, and then everyone realised, hang on a minute, the wind turbines are emitting loads of greenhouse gases. So yeah, I'll just write those down. What were those? So sulfur hexafluoride is SF6, and then H2O and NO2. Cool. I'm just going to write down. Yeah, NO2. So yeah, these greenhouse gases are keeping the heat in from the Earth, and what we worry about is that we will approach tipping points that will stop what we currently have, which is this very rapid increase in CO2, which is theoretically reversible, and take us to a point where it can't be reversed. We can't reverse the increase in CO2, and it will just keep going up and up and up and up and up, way beyond our control. So, trees. This is one of my favourite tipping points, just because I really like trees and I really want to protect them. So as the world heats up, what is happening to our forests? What's happening to our forests? And the illustration of this is really what's going on in what went on in Australia, or what is still going on to an extent in Australia as well. Kieran's asking if O3 would count as a greenhouse gas. So O3 absorbs ultraviolet. I'm not sure how much O3 absorbs infrared, which is the one that's carrying heat. I need to check up on that, actually. And CFCs, I think, do act as a greenhouse gas, chlorofluorocarbons, because I think they do absorb the infrared radiation, which is the heat radiation. But we mainly think of them as destruction of ozone, but they do also act as greenhouse gases too. What are meteoroids? I don't know the answer to that. Okay, Japan maybe let's talk about the paper falling. I'm going to talk about paper in a mo. Okay, yes, forest fires, exactly. So as the world dries out, and as the world gets hotter, a lot of forests that have evolved for hundreds of thousands of years to cope with these nice, wet, not too hot climates will suddenly find themselves super dry, and a lot of them will burn down very rapidly, and a lot of trees just won't be able to cope with the changing temperature. So like the big baobab trees in Africa, which are so beautiful, and I wish I had a picture for you now, but you should check out this tree afterwards. It's one of the most beautiful looking trees, and they've become a big symbol for the climate changing, because they suffer so badly from it changing so rapidly, and may completely disappear. Baobab trees, they're so beautiful. Anyway, so yeah, as the world heats up, these forests are going to get drier. They're going to start burning a lot more easily, and this counts as a tipping point because the burning of the forest releases more CO2 because it's burning. And that CO2 is a greenhouse gas, which makes the atmosphere hotter, which makes the forests drier, which makes them burn even more. And it's even worse because the existence of the forest is needed to remove CO2 from the atmosphere, because the forests store CO2 and lock it up. So this is a really problematic tipping point. Can the forests absorb enough CO2 quickly enough to reverse this, or will it keep going the wrong way, where we'll keep pushing it, and there'll be so much CO2 that the atmosphere will get so hot that loads of the forests will burn down, and they also won't be able to absorb CO2, and that would be a big tipping point disaster. Okay, Japan Maple's talking about if we all search with Ecosia. Ecosia is great. Ecosia is really good at, although Ecosia is often, I always search with Ecosia, or try to, but then if it's anything remotely complicated, I have to switch to Google, because Ecosia's algorithm's not that good. For those who haven't heard of Ecosia, Ecosia is the search engine that's kind of like Google, but every time you search, it gives you points. And when you've hit about 24 points or something, they'll plant a tree, because they basically take the money that they get from advertising on there and they just put it into tree planting projects, which is kind of cool. Yeah, big fans of Ecosia coming in. Yes, guys, nice. Adansonia, I'm not sure what that is. I'm trying to figure out where that's come from. Adansonia is the actual name for what? Oh, I can't tell what that is. Okay, but Kieran is talking about how some trees do rely on bushfires to grow. So that's right. In Australia, the kind of well, the wetter areas at least have this kind of balance between what's called a temperate rainforest, so like a cold rainforest, which is mainly like your sassafras and your old beech, and that's balanced with the eucalypts that actually love forest fires, because the forest fires create destruction and allow them to dominate because they can grow so quickly. And so the eucalypts do actually quite depend on forest fires for their cycle. But that's something that people say is be like, oh, the forest fires are fine and they're natural, and they are to an extent, but there shouldn't be so many of them. And the fact that there are so many of them will destroy so many of this more temperate rainforest, which is actually a lot richer in biodiversity and a lot more important. So in general, it is a good rule of thumb to say that the forest fires are a bad thing for nature. Although obviously there are some elements of nature that do benefit from them. Okay, right, so. Oh yeah, it's Earth Day. Happy Earth Day. This is a good day to be doing this one. Happy Earth Day, one and all. Okay, right. This chart is one that I think I've shown to some of you before, but I just want to go over it again. So this is one that is now a bit out of date. I remember looking at this in 2016, so like 4 years ago now. And this is, so I'm gonna just explain to you what this means. Let me bring up the dates at the bottom so that you can see. Ooh, there we go. So yeah, this is January, February, March, April, May, June, July. So this is going through the year, and this shows you how much. In fact, does anyone know what this shows you? Let's see who remembers. So what does this graph show? And meanwhile, I'm just going to quickly catch up on a bit of chat. And Angel's saying that they're going to suggest to their university to use. To switch to Ecosia. You should. All universities should be searching with Ecosia. That is for sure. And Japan Maple, Jeff, and Kieran are all saying sea ice area. And Pumpkin Master saying it peaks in December, so it's maybe frequency of Christmas tree use. Right, it's sea ice area. Now the it's the area of sea ice in the world. Now, obviously, this goes up a lot in May, June, July, August, September, October, which we often, up here we associate with the summer. So it's like, why is the sea ice so high then? Why is the sea ice so high in this region and so low in the middle of our winter in Japan, February, March? What's going on here? Why do people think the sea ice is so high in this part and so low over here? Does it say down the bottom what it is? Oh, maybe if you... Oh, yeah, it does. It says global sea ice. Haha! People who have sneakily detected what it is. Max says Katanaraka. So do they have charts of sea ice for even earlier, like pre-industrial? Not for sea ice coverage, I don't think. I can talk about where our charts came from for CO2 levels. In fact, I'll do that in just if I get a chat. Will I get a chance? No, I think I might not get a chance to show you that. But anyway, I'm going to focus on this. So yes, this is. The reason why it's so high in our summer is because this is the winter in the southern hemisphere, and most of global sea ice is dominated by Antarctica. So this is more the winter in Antarctica, and that's where the sea ice is so high. Now, this chart shows you a line for every single year from 1978 through to 2016. And what you can see is that the lines are a bit wobbly and they're a bit shaky and they're a bit noisy, but ultimately every single line fits nicely within this smooth grey curve. You can see the grey colouring here. Every single line fits roughly inside that grey curve, and has done for many decades, following this nice oscillation here. And that's the kind of thing that we expect in the world, like things generally follow similar patterns. Now, in 2016, it started off a bit low, and we were like, okay, that's the lowest it's ever been in February, March, but it's okay. And then it kind of went up again, and it was fine, and it was absolutely fine. And then we hit September, and then something happened that was so scary to the scientists who were watching this data. And I remember seeing this and being like, oh my God, like the world is about to collapse. Because we saw this huge diversion from where the pattern normally goes. And the sea ice level just did not go up in September and October. It just dived down here. And this was one of the first things that people saw, and we were like, whoa, like this is the tipping points happening. The world is going to very suddenly change. And really, like, thankfully, the last few years have been a bit closer and a bit more up here. And they've been following the pattern a bit more. But, you know, there are other factors that could have caused it to start following the pattern more as we continue to increase our CO2 levels. And it's quite a scary thing to see this pattern diverge so much. And so this is something that we think of as could be quite a tipping point. So who knows why sea ice is considered one of the most important tipping points? And I'm going to draw you a nice picture of Antarctica as a square, and the Arctic. In fact, this can be the Arctic. So here's a nice square Arctic. Why is it that the sea ice in the Arctic is considered a potential tipping point for our climate? What do you think? Why is that a potential tipping point for our climate, the Arctic? And meanwhile, I'm just going to read what you guys are saying. And Angel's saying, oops, can't spell. Everyone in America pronounces Antarctica Antarctica is what I keep hearing them say. I don't know why they say that. Interesting. I guess they say aluminum instead of aluminium. And so who's this? Sicto is saying, would you say anthropogenic global warming? So anthropogenic means human caused. Would you say that human caused global warming is more dangerous than the general destruction of the natural world? I think the two are completely intertwined. It's all part of the same thing. What a lot of people aren't seeing is that they think, oh, we just need to reduce our output of CO2, and then we need to create technologies to reabsorb it. That's the wrong way to think. The best stores of carbon around the world by miles are the natural systems. The natural systems are where the carbon is locked up. The best carbon stores are rainforests with incredibly healthy soil and biodiverse populations, because that's so much life that stores all the carbon, like kelp forests off the coast of the ocean, full of life and fish, and that's a big store of carbon. Destruction of the natural world is anthropogenic, is human caused global warming, because whilst it may not be directly creating the CO2, it's destroying the systems that can absorb it. So yeah, the two, like, this idea of like destruction of nature or destruction of biodiversity as being separate from climate change, it's yeah, we shouldn't be thinking that way. We have to pull these ideas together. And okay, right, here we go. Max saying that's incredibly scary. It was incredibly scary, but it's not. It's been oh wow. Kieran's saying there are thousands of reasons for ice. And Miz is saying penguins need a place to live. Yeah, but penguins don't live in the Arctic. That's for polar bears. We talked about this before. Okay, so Izzy's coming in with saying the area of ice affects the albedo, which is this is exactly what I'm talking about. That this is the main point that I wanted to get to, because it's the most clear kind of climate tipping point. That's a very physical one that we can see, and it's, again, this is not talking about nature. This is not talking about natural systems so much. This is just talking about the Arctic. So when sunlight hits the Arctic, it's bright white, and sunlight hits it and it just bounces off again back up into space. It's like a big shiny mirror. Think about how if there's ever loads of snow and really bright sunlight, it's really piercing for your eyes because it's just bouncing the sunlight back. The Arctic is a mirror bouncing the sunlight off, sending it back into space, being like, see ya, we don't want you here, and gets rid of the heat, right? And so this is a big mirror that's reduced, and this effect is, there's a technical word for this, and this effect is called albedo, and which is the ability of the surface to reflect heat back off it again. Now, as the sea ice disappears, it is being replaced with a surface underneath that is a nice dark ocean. And dark water is exactly the kind of surface that will absorb the sunlight coming in and hold it as heat. which makes the oceans warmer, which makes the ice melt even more, which means that there's even less heat reflected, which means that even more heat goes into the ocean, even more ice melts, and you see how it tumbles and tumbles out of control. So this is another tipping point, another thing that can push out of control. Now, this is a kind of, I showed, oh, wait, there's a nice seal. I love seals. Okay, so I showed a picture like this before of the Methaneclathrates in Alaska. So this is in the north of America, and what you can see here is some people have set fire to the gas that's coming out of melting ice, because inside, what's worse about the ice melting is that inside it is loads of methane, which is one of the worst greenhouse gases. Do you guys know? I think I asked this before. How much stronger is methane as a greenhouse gas compared to CO2 if you measure it over 100 years? If you measure over 100 years, how much worse is methane? Sorry, this is methane. How much worse is methane than CO2? What do you guys reckon? And I'm just going to catch up on chat. Okay, Angel's also talking about how the Arctic is important for temperatures in the ocean, which impacts the air temperature. So yes, the temperature of the Arctic also impacts air temperatures and ocean currents as well, and disruption of the ocean currents will force a lot of the biology in the world to change. And the problem with biology is that it cannot cope with rapid changes. It can't cope. Like if you gave all the seals a few 100,000 or millions of years to evolve legs and get back on the land again, they'd be fine with it. They'd be like, yeah. Give us a couple million years, chill. We'll get ourselves back on land. We'll evolve back some legs, fine. But we're not giving them that much period of time. Instead, the rapid changing of the climate is giving them mere decades in which to adapt to something that they can't possibly adapt to. And so loads and loads of nature, loads of biology will be destroyed by the rapid changes that are being caused by climate change if we don't turn it around. Okay, Japan Maple just said that apparently aluminium was discovered by an American who pronounced it in the American way, and then the British changed it to the end with ium, like lots of other elements. That's so interesting. Okay, Japan Maple, thanks for that. So it turns out the Americans are right about aluminum. I'm going to remember that. And Oliver had a great answer for albedo of the ice. And Jeff's talking about how strange Australian slang is. There's so much chat about aluminum. Apparently there's a camera where you can watch the penguins in Edinburgh Zoo. Interesting. So what if we painted America white so it reflects heat? I mean, yeah, we could paint loads of the surface of the Earth white, and that could be good. Okay, so here are the numbers coming in about how much worse methane is. So methane is about 84 times worse. So it's actually really nicely in the middle of all your guesses. You know that thing where if you oh no, there wasn't one as high. Oh yeah, 100 times. Yeah, it's about 84 times worse than CO2 measured over 100 years. If you measure it over 20 years, it's even more worse. I think it's about 150 times stronger than CO2. The thing is, we talk about measuring it over a certain number of years because methane doesn't last as long. Methane will only last a few hundred years, whereas CO2 will stay in the atmosphere for hundreds and thousands of years. And so over long periods of time, CO2 is worse, and over short periods of time, methane is worse. And this feeds into the whole battle about like animal farming, like huge animal farming of cows and sheep. And I should probably I'm going to do a whole live actually on cows and sheep and meat and why and what the arguments are for and against those things. I myself don't eat beef or generally don't eat lamb as a rule, and I very rarely eat meat, and I'll explain that to you another time. I try to stay away from like animal products in general. Anyway, I'll explain that to you another time because that's a really interesting climate story. And I'm sure you guys all have your views on that. Food is one of those things that people get really, really emotional about. So I'm kind of interested to know actually what a lot of your viewpoints are. Okay, so Jasmine's saying, no offense, but humans are really stupid. Jasmine, we're actually all humans on this chat. I don't know who you thought was chatting here, but Actually, that is pretty rude. But no, you are right. It's that the humans have kind of messed up a lot of the planet a lot. Anyway, as the ice melts, this is a tipping point because this permafrost, i.e. ice that is permanently ice all year round, normally, is melting and releasing methane from an ancient atmosphere that used to have a lot more methane in it, and also from methane sources that are building up the methane underneath it. And as it releases methane, methane's a super powerful greenhouse gas, heats up the atmosphere even more permafrost melts, even more methane is given out, heats up the atmosphere even more, and it goes round and round. And these things are called tipping points, and people who study climate are like, I study chemistry, but I've done a lot of studying of climate, and these things are terrifying because we don't know when they're going to suddenly go out of control. Now, here, I want to show you something quickly with this piece of paper. This is, some of you might have seen this before. Right, now if you think of this piece of paper as the stability of, it's got a light bright dot on it. If you think of this piece of paper as the stability of the climate, then as you add greenhouse gases to it, you can imagine it kind of going up and becoming more and more unstable, right? And if you keep adding greenhouse gases, eventually it will collapse. And so you reach some kind of tipping point. Now, a lot of human thinking is like, oh, well, we'll just wait for things to go bad and then we'll start acting on it, because that's how humans often deal with things. But the problem is that if I move my fingers back up the piece of paper a little way, the climate doesn't go back to how it was. In fact, I have to move my fingers really, really high, all the way up to there, before it rights itself again. Because the climate is not reversible in the way that a lot of humans hope it will be. The problem is that once we reach a tipping point, it becomes a lot harder to pull everything back, and that is why it's so important that we're all fighting for climate action and climate justice. And right, it's coming up to 2:39 now, and this topic is so big, and I should definitely do more on these. I am going to do more on climate ones in general. But yes, what did I want to finish on? Well, I'm just going to show you again. This is another beautiful picture of Comet West, because Comet West is super cool. And that's that bright comet that appeared in the night sky not very long ago. But yes, to finish, I think let's talk about I'm just going to quickly talk about COVID. So a lot of people are talking about how, there's this thing that goes around the internet of like, oh, COVID's really good for climate change. And I don't think that's a good way to talk about it myself, because COVID's like a terrible thing for many, many people. And I don't think that's a helpful way to talk about it, because the thing about climate change is that it's a problem for all humans on Earth. It's just that a huge number of humans don't actually realise anywhere near how bad it is at the moment. And so the challenge is bringing everyone on board and getting everyone together and being like, actually, hey guys, like this is a problem for all of us and we really need to work on this. And so I think with climate, we have to be careful with the language we use around COVID, because we have to not make people think that we're kind of, that climate activists are using COVID as like a way of saying, this this shows us. Do you know what I mean? Like we shouldn't be piggybacking on COVID in the wrong way, because I think that would be a very insensitive thing to do. But I think it is very important to talk about it in a way where we consider the things that have happened during COVID of showing that the world has been able to shut down in a way that we can then use in some way that's a bit similar. And we can't do it in the same way, because the shutdown of the world currently will have destroyed loads of people's livelihoods, and it's something that will be very difficult to do in practice. But we can certainly learn from it, and we can learn from it some things that will work. And we certainly do need really radical action on climate change, because as you can see, these tipping points, like that I've been showing you all over here, they're still happening. We're still approaching them. We're still terrified of them. But what we need to do is we need to continue to protest for large systemic change. And that's why personally I do a lot of protesting for climate and a lot of climate activism, because we still need the same things. We still need to basically shut down fossil fuels and protect our nature. And those are the key things that we need to do. And I think that there are ways of doing that, and I know that a lot of people agree with me as well, and that there's a lot of thinking in this way, there are ways of doing that that can be positive for the planet and can still bring most of the world population along with us. Anyway, that's not going into a whole other world of stuff. I'm gonna just look into the chat quickly before I go. I'm gonna finish up there. But if anyone has any last questions for me, because I know I've blasted through so much information, throw them into the chat now, and I'll hang around for a bit and just answer a few last things. I just saw Jasmine say I want to crunch ice right now. Why? Is that looking at the seal and its icy whiskers? Okay. Right. Yeah, just kind of catch up on the chat. Loved the paper analogy. Oh, thanks so much. That's nice for you to say. And the Kanye Comet West. And Max is saying that, yeah, there's this crazy thing going on in America at the moment where a barrel of oil is now costs negative money because the suppliers are paying people to take it away from them so that they don't have to pay storage costs, which is totally mental. And we should just, we really need to just leave all the oil in the ground. And Jasmine's asking if I could put a top hat on the seal. Yeah, I can pop one on quickly. Quick little top hat. Nice. And climate change is leaving people behind. Action will create more equality. Japan Maple, that is such a beautiful point. Yes, action on climate change will create more equality and bring people together. Because there's one thing that humans are good at, it's uniting against a common problem or a common enemy, and action on climate change will certainly do that and create a much better planet, I think, for everyone. Even though it has to be done in the right way, and I'm very much about action, but I just I just know that this time is a very difficult time for a lot of people, and so I always worry about the wording that people use around mixing COVID and climate change. Max is making a potato and carrot field and wondering what I should do to prevent topsoil loss. Right, I'm gonna do a whole live on soil later on. I think that one's coming up. I'm not sure when, but I will do that as well because that is a great question. Anyway, thank you so much for everyone who came to this one. You've been great. So many questions in the chat. It's been so fun to try and keep up with them all. Please do spread the word about AimHi. Tell your friends and family. Thanks for coming along, and I'll be back again at 2 p.m. tomorrow for my next one, so do come to that too. And yeah, if you haven't already, it would be amazing if you could answer those questions. I think where have I put them? Let me just grab them so I can shove them into the chat. I should have prepared them earlier. I will send you these things. Yeah, so this, if anyone had the time to fill out that would be that would change the game for us, because then we can know when to run the, like, one of the big questions for us is like, when should we actually run these that the most people are going to be able to benefit from them. So yeah, if you can fill out that would be the dream, and if it didn't come through, it should come through now. Yes, thank you so much all. I will see you tomorrow. Have a nice evening or morning or whatever time zone you're in, or a good sleep, and yes, farewell. Bye bye.